Get this thing to move to the next page. The instantaneous rate of change and piecewise functions. So I'm giving you a graph of the absolute value of x minus 3. I'm asking you to find the instantaneous rate of change at x equal to 3. Well, this is an absolute value graph, and what we do is we actually break it apart into a piecewise graph. And the pieces that we'll be using, we're going to use one piece where x is less than 3, and another piece where x is greater than 3. And the equal sign, you can decide where you want to put it. You just can't give it to both. So I'll give it to the second. And the way that we do this is the left side of the graph is the part that actually differs from the equation. The right side of the graph here, that is the equation of y equals x minus 3, exactly what you see here. The other side of the graph is going to be y equals the negative of the equation. And so the left side of the graph is equal to negative x plus 3 instead. So let me put that in here, negative x plus 3 and positive x minus 3. And that makes our piecewise function. So I'm going to go through and do this example. Given the function of x, negative x plus 3, where x is less than 3, and x minus 3, where x is greater than or equal to 3. And if you put the equals in the top or the left function, then you'll still come out with the same answer. So this is the left side of the graph, and this is the right side of the graph. And that's really going to be important because the slope of the tangent line or the instantaneous rate of change, it's really coming from limits. So what we have to do is we have to find the limit as h goes to 0 from the left side first of f of x plus h minus f of x over h. So what that means is we're going to find the limit as h goes to 0 of f of 3 plus h, because we're trying to find this at x equal to 3, minus f of 3 over h. Now at x equal to 3, we already know y is 0. You can tell that by substituting in the value or looking at the graph. The issue is right here. When you're doing the left limit, you will use the left curve, which is the negative x plus 3. So when I do the left side of this, I will be doing the limit as h goes to 0 from the left of negative 3 plus h plus 3. So what did I just do there? F of 3 plus h. I used the left side of the function, and what I found was negative, and put in your 3 plus h for your x, and then add 3 at the back. Then I'm going to subtract f of x. Well, f of x is 0 divided by h. And this cancels. Negative 3 will end up canceling with the positive 3. So you get left with the limit as h goes to 0 from the left will be negative h over h, which gives us negative 1. If you look at the graph, and I'm going to take you back to the graph after we do both, you'll see that the slope is definitely negative 1. Now we're going to do the right side. So I'm going to actually try to squeeze it in right here. Hopefully it'll fit. Limit as h goes to 0 from the right would be f of 3 plus h, and I'm going to put a little star here and put f of 3 plus h. This time I'm doing it from the right side, so I'm using x minus 3, so 3 plus h minus 3. Simplify that and you just get left with h. So we're going to have f of 3 plus h from the right minus f of 3 all over h. We have the limit as h goes to 0 from the right. So f of 3 plus h from the right was this pink h right here, minus f of 3, which is 0, all over h. You get left with the limit as h goes to 0 from the right of just h divided by h, which is 1. You simplify that first, giving you 1, and it's a constant function, so when you try to do the limit as h goes to 0, it still is itself, which is 1. So I have that the left limit was -1. The right limit was +1. Let's go back to the page before. So what we found was that the limit as h goes to 0 from the left, that would be this side, that slope was -1. You can physically see that in the graph. And you go from the right side, that slope was +1. And so what I'm going to do is I'm actually going to steal this graph. And let's go over to a blank page so that we can write all over this thing. So the slope coming in from the right, the limit as h goes to 0 from the right of f of x plus h minus f of x all over h, that was 1. In blue, coming this way, the limit as h goes to 0 from the left of f of x plus h minus f of x all over h, that was -1. What do we know about limits? We know that if the left-handed limit, and I'm going to abbreviate so I don't have to write out the whole entire difference quotient, if that equals the right-handed limit, then the limit exists. Well, in this case, we have -1 and +1. Therefore, the limit as h goes to 0 of f of x plus h minus f of x over h does not exist. What that tells us is that the slope at x equal to 3 does not exist. And graphically, what that tells me is if I come in from the left, my slope is -1. If I come into the right and my slope is +1, that means when I reach 3, the slopes are different. The slopes, not the values, but the slopes. So when you're looking at a piecewise function or you're looking at absolute value function, doing the limit as h goes to 0, you got to do it from the left and from the right. And the only difference is when you substitute in your values. You're substituting, if you're going from the left, this f of x plus h, we use the left function. And when we did it from the right, we use the right function. And I believe that is everything I wanted to show you.